Hello, everyone, and welcome to the DOE Python Exchange. We are very excited to get started as we have a fantastic lineup of guest and host panelists to share with you today, and we will actually jump right in. First, I would like to introduce our guest panelists for today, Matthias. Matthias, if you want to say just a little bit about yourself and what project you're here to share with us today.
So hi, I'm Matthias. I have been a Jupyter core developer for slightly over 10 years, since before it was named Jupyter. I've started that during contributing during my PhD, and I'm currently a software engineer at QuantSight. And today I'm going to talk a bit about the growth of the Python ecosystem and with a focus on documentation and a project I've been working on for the past year and a half to try to improve documentation in Jupyter called Papyri. We'll get into more detail with the presentation.
Fantastic. And Matthias, if you could let us know, what types of questions should we ask you? Is there a general category that you would love to hear?
Well, I'm happy to answer anything, maybe not my credit card number and social security number, but otherwise I'm happy to go into any directions that you like to go.
All right, fantastic. Matthias is ready to field any questions. So if you're in the audience, please drop questions in the Q&A widget. We'll make sure we get to as many as possible. And on our host panelists today, we have first up, Matthew. Matthew, if you could tell us just a little bit about yourself and what you're an expert in, what types of questions do you want to hear about today?
All right, sure. Hi, everyone. So my name is Matt Carbone. I'm an assistant computational scientist at the Computational Science Initiative at Berkeley National Lab. So this is actually my first time doing this, so awesome to be here. Thank you for having me. My specialty is all over the place. I do a lot of condensed matter physics, computational spectroscopy. That's kind of my domain science focus. And on the software side, I work a lot with Dan Allen at LBNL. We design pipelines for spectroscopy data primarily. The types of questions you can ask me whatever you want, barring my, credit card or social security number or whatever. But my specialty probably lies somewhere at the intersection between the science of physics and chemistry and software. So if there's questions like that, I'm happy to field those.
Fantastic. Well, we're very happy to have you here, and I know it's your first time, but we are very excited to hear your input on today's discussion. And Thomas, next on our guest panelists, can you tell us a little bit about yourself and what types of questions you are here to answer for us today?
Hi, so I'm Tom Caswell. I'm also a computational scientist at Brookhaven National Lab, but in NSLS2. In addition, at NSLS2, I work on high-level data acquisition and data management, also with Dan Allen. With a slightly different hat, I'm the project lead for Matplotlib. So I'm happy to field questions about scientific Python in general, visualization, and how to run a large community project.
Fantastic. It's great to have your expertise here with us today. I know I have been using a ton of Matplotlib recently, so I'm very eager to have you with us. Next up, I will go ahead and introduce myself. My name is Cameron Riddell. I used to be a grad student at the University of Davis, California, where I studied cognitive sciences. I have a background in analyzing neuroimaging data and acquiring neuroimaging data through experiments, as well as in my field, I studied human memory, the perception of taste, the perception of pain, and a lot of different psychological aspects. Today, I work with James Powell at Don't Use This Code, and I am a technical lead where I do a lot of programming and events like this. So with that being said, I would like to let James Powell introduce himself, and we can get today's discussion started.
Hi, everybody. I look a little different today because I'm not in the New York studio. I'm actually at PyCon Lithuania, about to keynote in just a couple hours' time. I think a very relevant question that I would love to hear from some of you today is, what is there in the broader community outside of just events like this? If I want to take some open source code that I'm developing, or if I want to find some meeting of the minds with people who are outside my little bubble, what kind of events, like for example, PyCon Lithuania, might there be that I might be interested in engaging with? With that said, I am also one of your host panelists for this event. I work together with Cameron at Don't Use This Code. And Cameron, if you would like to bring up your screen, I can even segue us into our very first activity for today. Today, we're going to get started with a simple extracurricular activity, as we typically do. But today's activity is very slightly different. On the screen right now, you can see a couple of choices. And one of the things that we experience when we try to share what is available in this Python scientific computing ecosystem with scientists at labs is that there's a lot of tools and a lot of choices. And so I'd like to start off our host panelists with a simple little game that we're going to play. The game is pick two and tell me why or how to choose. The host panelists are going to be asked to look at the screen and pick two of these 14 different choices for core data structures out of just 3 libraries, NumPy, Pandas, and Xarray, and to explain, well, why would somebody choose one of these over another? And we might repeat ourselves a little bit. We may even find that there are multiple distinct reasons, but I'll start you off really simply. If I were to choose an interesting contrast, I would say between number 4 and number 5, the NumPy array and the NumPy matrix. Historically, we needed the NumPy matrix in order to make sure that when you perform a multiplication operation between 2 structures, here you can see the example is a little bit hokey, but between 2 structures, you're performing actual matrix multiplication. However, with the introduction of the matrix multiply operator, the @ symbol, in Python 3.6, we no longer really needed the numpy.matrix in order to disambiguate between whether we meant element-wise multiplication or matrix multiplication. And as a consequence, I don't think that there's a really compelling reason to use the numpy.matrix anymore. I'll even say this, I struck one possibility off the board for you. How about we open it up to the rest of our host panelists to see if they want to try their hand at this game?
Definitely. Matthew or Tom, is there anything just jumping out at you that you want to address?
I would say you're missing my favorite data structure, which is a dictionary of NumPy arrays.
Good old Pandas 0.01, right?
So Tom, why would you choose that in contrast to one of the choices on the screen?
I would choose that because I typically work with data that is best represented as a NumPy array. It's just a flat, array of some shape. I don't necessarily need the guarantees Pandas gives you of that everything in it is the same length. I don't necessarily have an index that makes sense for this data set, but I do want to carry around with names 4 or 5 arrays that belong together for a logical reason. So they may not be they may be the same shape, they may not be. They may not have any way to sensibly correlate them together.
Tom, could I even suggest that there's maybe an analog here on the screen? Number 1, the only reason you'd really use a list in the case of having some sort of numeric or mathematical data is because you want to store like entities. And I think what you're describing is basically taking a bunch of like entities that aren't index aligned, storing them together with a little bit of naming as just a dictionary of entities, a dictionary of mathematical or computational results or something like that. Is that about right?
That's about right.
Matthew, anything in here jumping out at you?
Well, lots of things are jumping out at me. Let me see. What do I want to pick? Should I keep it simple? I'm going to keep it simple, just for fun. All right.
Yeah.
So let's do the. Oh, actually, I'll fire back a question to you guys. Right? Is it tuple or tuple?
I always say tuple.
Tuple.
Very fancy.
As a French, I didn't hear any difference in what you said.
All right. So I'll take number. I'm gonna play devil's advocate because we just got done saying the only reason to use a list, etc. So I'm gonna choose 1 and 2, just because I'm boring like that. So to me, right, the most and I also like to choose 1 and 2 because they're very Pythonic. They're like fundamentally Pythonic, right? Even the NumPy library is not pure Python. So The list is when you want to have a gathering of like things or even unlike things in Python, because you can do basically whatever you want in Python. And the tuple or tuple, the list of those things is, I would say, usually most used when you don't want what's in the tuple to change, because tuples are immutable. So if you have a list of things, well, okay, also you kind of have a list of lists in two, right? But if you want things to change, you don't want to use a tuple. If you think you're going to modify something, you don't want to use a tuple. But if you think that you're not going to change anything in that list, so in other words, you couldn't access the first entry in 2 and just say, entry 0th, right, index, which is A, equal B. It wouldn't work. So yeah, that's when I would choose between 1 and 2.
Yeah, that's great.
I can try to compare 2 and 3 then while we are there. If you need to serialize the data, for example, I would go for serializing 2, because if you serialize 3 as JSON, for example, your file will be much bigger, as you have to serialize all the keys. And if all your keys are identical and you have a large number of records, you would go to something like 2. There is better than 2, of course. You can, if you have more structure, you would go to something like an X-array or something like that might be able to compress your data and have better access.
Yeah, I like that. I hadn't even thought about, the size of what you're serializing in order to serialize the keys.
What about number 10 with something like arrow?
Yes, that would probably be better. But again, if you want to serialize 2 or 10, you need to have uniform data. If you know that your data is uniform and every entry is the same and have the same structure, then you can use something like that. But if you have unstructured data, like a tree or something which is more complicated, then you will have a difficult time making it more compact, or even serializing it in a format like arrow than 3 with JSON.
And what do you use for serializing messages for Jupyter? Hopefully not a list of tuples?
No. So it's using message pack, which is, depending on how you configure it, you can give it some information about the JSON you send, and it can be slightly more efficient. But Jupyter has been designed more for human readability than for efficiency, because we do want Jupyter to be easy to hack. And I don't know, in 200, 300 years, when you have digital archaeologists who will go through the metaverse, be able to understand what is in Jupyter. So we try to avoid binary protocols that need magic's number if necessary for something which is readable. And so, for example, binary data, like images that are sent from the kernel to the front end, are actually base 64 encoded, which adds quite a bit of overhead.
Oh, that's very interesting. Didn't know that.
I'm curious to hear from Tom a 3-way difference between number 1, just a list, number 4, a NumPy array, and number 13, an X-array data array. When you work with your Beamline staff, Tom, when do you tell them you need to use NumPy for this? And when do you tell them, take that back, you need to use NumPy wrapped with an X-array data array for this?
So I think a series of sophisticated data structure knows more about itself. So this is just a that's a thing that could be a number list. When you write that you're going to want to work on and bulk, you're going to escape Python and say this array on it. The umbrella name no because you can check as the size.
I'm having a lot of trouble hearing.
You
Just
want
throwing that out there.
to go? Is that any better?
It's stabilized a little bit, yeah.
Maybe if I turn my video off. How's that?
Yeah,
That's
I can
better.
hear you clear.
Okay. So I was saying the list is good because you can literally put anything in it. You can work out it in Python. The NumPy array is great because if you have numeric data, NumPy arrays are really a wrapper around a C array. So you can get very efficient math. You can pass that off to any C or Fortran or C++ underlying library to do fast math. But the array still doesn't know its name. It doesn't know anything about its indices. It doesn't know that you shouldn't add you shouldn't be able to add the latitude or the longitude. It just says these are the same length, so I can add them. Whereas with when you go up to an X array, it now knows its name, it knows its dimensions, and it knows a lot more about itself. And if you try to add the latitude and the longitude, it will say, I can't add those directly. I have to do the outer product and give you a 2D answer back instead of the inner 1D product. And so the more you can teach the tool about itself, the better job it can do helping you.
That's great. And I love how the data array just gives us access to much more kind of human readable code. Because like you mentioned, all of a sudden I'm writing code that says from my array, get me the latitude, not from my array, get me the 0th row or the 0th column. Right. I think that's a great explanation of when you should use a list versus a NumPy array versus a data array from it.
I think maybe more subtle is maybe if we compare the pandas data frame to the data array of X-array. And my understanding is that the data array of X-array is more dense, regularly spaced data where nothing is missing, while pandas will maybe be seen as less structured, mostly two-dimensional, unless you want to consider some of the tools of reshaping arrays in pandas as being like more dimensional, but differently. You analyze studies. I see pandas, for example, a lot in social science. What I won't see X-array in social science, when X-array will be used in climate science, for example, but not pandas.
Matthias, you stumbled upon a very interesting comparison, because if you look at the X-array documentation, they liken the X-array data array to the pandas series and the X-array data set to the data frame. And the analogy that they're making is a pandas series is one singular measurement that somebody has taken, where that measurement happens to be one-dimensional. And a data frame is multiple distinct measurements they've taken, where each individual measurement is one-dimensional and they're aligned in some fashion. They were taken on the same physical space. Whereas an X-array data array is one individual measurement that was taken, but that measurement happens to be n-dimensional, like a surface or an image, and the data set is multiple distinct measurements where they happen to be each n-dimensional. One might be one-dimensional, one might be two-dimensional, one might be three-dimensional, and they have some sort of common frame of reference, not an index, but a common coordinate system or set of dimensions. I found that correspondence very tricky when I started using X-array, until I really thought about it in terms of how many distinct measurements am I taking? And I started thinking about pandas data frame and the X-array data set as collecting together multiple distinct measurements alongside some sort of common coordinate system, or in pandas terminology, an index. But I have a question for Cameron, and I think we can take maybe one or two of these before we wrap this up. But Cameron, you are a pandas expert. When do you use a NumPy array, number 4, versus number 6, a NumPy masked array, versus number 8, a pandas array with a capital I in64D type, or even more basic, what the heck is that capital I in 64D type in the first place?
Yeah. So NumPy array, I would say if you need to perform any type of mathematical computations and you have homogeneously typed data, meaning everything's an integer, everything's a float, or it can be treated as such, This gives you access to be able to perform very fast computations along these data on any given axis. However, as we've touched on already, right, you have to access into your NumPy array using somewhat arbitrary numbers, and that's where you would use something like the data array if you want to name accession into your NumPy type array. And I believe next up was the NumPy masked array. So the NumPy masked array is slightly different than your standard NumPy array. It essentially uses a Boolean pattern to represent, I should say, missing values from your data. There's two kind of approaches that you can use to represent missing values. As we always see in NumPy, you see that nan popping up everywhere, and it'll force your data type to float all the time. And so when you want to represent, say, integers, right, and have missing data at the same time, you can use a masked array without having to use the NumPy's nan or cast your data to a float to represent missing data. It all depends on how you want to represent your missing data, either a Boolean mask or sentinel values. The Pandas D-type capital I N64 was released, I believe, first in Pandas 1.0, which was just a few years ago, 3 years ago, I want to say. This essentially gives you the ability to insert a Pandas null or not a number into int64 data typed Pandas series or Pandas arrays. Now, this is a little bit different from the NumPy not a number because we don't actually have to coerce our values to a float data type in order to work with it. So a lot of people just ended up complaining and saying, hey, why does Pandas always coerce my data to a float data type whenever there's missing? It was because it's built on top of NumPy, and NumPy only had the float nan for a null value. So Pandas added just a little bit of software layer on top of NumPy to include this integer NA, which is that capital NA you see down here. And you have access to, again, representing missing data without having to coerce your data to some float type in order to bend into NumPy's restricted computation domain.
Now, I think a very technical question.
Go ahead, Tom.
So an integer uses all of the bits of its number. Where did they stuff the flag?
You're absolutely right, Tom. You can think of this as an in-band versus out-of-band encoding problem, whereas with a masked array, they use an out-of-band encoding. They have a separate parallel structure. With the in-band encoding problem, no, the only way to solve the is this data, is this metadata, is either through partitioning of the space, that's what float does, or some sort of escaping, quoting, or prefixing approach, none of which are possible with the int data type because it uses all of its bits. The Pandas array, or the extension array, allows you to represent data separate from metadata in an out-of-band encoding. The int64 with a capital I array in Pandas is actually under the covers, more or less a NumPy masked array. It looks very, very similar. It's just implemented slightly differently. And it just has a mask as a separate piece of data. But it's really just the data and the mask in completely different structures.
Yeah, you see that it's a very common pattern. I mean, I think, in my opinion, that is the purpose of the Pandas array, is essentially to wrap some underlying, usually a NumPy array, add a little bit of metadata on it so that you can treat it just somewhat differently. You see this, NumPy supports date times, whereas Pandas also does, but Pandas also supports time zones, whereas NumPy does not. And that's implemented in the metadata layer on the Pandas array. And so you can kind of think of the Pandas array as just NumPy array with a little bit of metadata, and you get some nice fancy interactions because of that.
So you go ahead.
Go ahead.
You opened the door of date time. I recently had a question from someone I couldn't answer. How to deal with dates that are BC in Python?
Oh, man.
I think this is a great, great topic. Why don't we leave that for the Q&A after your prepared comments, Matthias, just so we can wrap this up, because I'm sure we're all very eager to hear what you have put together for us. One of the things that I think would be helpful for some of our host panelists to acknowledge is, for scientists beginning to use these tools for the very first time, there can often be an absolutely bewildering number of choices to do very simple things. And exchanges like this call I think, are resources that we want to provide to the scientific computing community to try and simplify their lives, to break things down a little bit, to make it easier for them to make these kind of choices. Just to wrap this up, I think it would be nice if our host panelists could speak just very broadly about the overall process that they use to simplify their lives when they're faced with these incredibly bewildering choices. There were 20-something or 14-something or so, over a dozen possibilities on that set of choices that we had to pick between. And so I'll start off very simply. If you're a scientist and you don't care about performance and you just want to capture some very small amount of data, pure Python is fine. All the Python types are fine. If you care about performance and you care about large-scale mathematical computations, then you probably need to use NumPy. If your data is multidimensional, you need to use Xarray, namely if it's 2 or higher dimensional, you need to use Xarray. If your data is strictly one-dimensional, especially if it's one-dimensional and time series, Pandas is a great choice. Do any of our host panelists want to see if we can break it down to just a really simple if this, then that, to help out some of our colleagues?
I would add one more thing, which is readability. Like most of the time, the pure Python data structure, if you have to write loops if you want to do custom computation, while most of the time, if you use any of the other library, you can do vectorization, which makes the code much more readable and much closer to the math. So usually you also have less bugs, which might not be true for everybody, but usually the more line you have, the more bugs you have.
Yeah, I think James, you gave a wonderful summary. I mean, to me that feels about right. As someone who does a lot of numerical scientific computing, my personal experience, I actually have used NumPy arrays for very high dimensional tensors. It's probably not best practice, but you can get away with it. But I totally agree that, yeah, if you're going to have lots of axes, you need to keep track of them. Xarray is probably the way to go. I'll add a few other things, just general comments. If your function returns like 10 different things, don't return thing 1, comma, thing 2, comma, thing 3. You will lose your track of things and lose your mind. Not to mention it's impossible to document that well. Return a dictionary, right? Just have a key that, right, tells you what it is. So, because your own worst enemy is you tomorrow when you reread your code, right? So you want to keep track of that. Return a dictionary. That's a great use for it. The only other thing I'll say, because I actually really do agree with basically everything James said, is, and maybe this is obvious and maybe this has been said at a different time, but if you're coding in Python and you're writing lots of nested for loops, look at NumPy and look at the operation you're performing, and go check out the NumPy documentation, because it's very likely whatever you're trying to do, be it a matrix multiplication, a simple thing, or a very complicated Einstein tensor operation or something, NumPy's got it, and it'll do it a lot faster than you can in for loops, right? So your code will be very, very inefficient if you do that. So when we're talking about doing math with NumPy arrays, right, we don't mean nesting for loops like you would if you're writing a C program or something. We mean calling the NumPy backend, right, to perform this operation.
I will also say name tuples to return from a function, which was one of the missing. And another criteria for choices is if you have colleagues, don't use something that you're only want to use. Use the same as your colleagues so that you can help each other.
I would say I agree with everything that's been said so far. I tend to start from the simplest possible code that will solve my problem, and then as it gets more complicated, I go up the escalation ladder of bringing tools in, right? So if I start with just a dictionary of lists, and I can get by on that, I stay with that. But when I start doing like lots of zips and going down the list together, or trying, notice I'm starting to implement group by, that's when I'll move up to pandas. Yeah, just leave the possibility of increasing to a more sophisticated tool as you're developing.
Yeah, I think that's a fantastic way to go about designing programs, right? Just get something through, get a prototype that works, and as you need to add complexity, add that complexity, right? Don't don't reach for the pandas or NumPy right off the bat if you don't need to do it, right? If you just need to add up a bunch of numbers in a list, they're already in a list, just use sum. Pretty straightforward, pretty simple. But with all that being said, I would love for Matthias to lead us into his prepared remarks today. I do want to remind everyone that there is a Q&A widget, so if you have questions at any point, please enter them there. We can field them with Matthias and our host panelists after the discussion that we have today. And with that all being said, I will turn the reins over to you, Matthias.
Okay, let me see if I can figure out how to share this. Can you see my screen? Or my slides?
Yes, we can see your slides and you perfectly.
Okay, perfect. Thank you very much. Thank you for having me today. And today I'm going to talk a bit like the needle in the growing haystack on how to find something you are not even looking for. I'm mostly trying to step into the shoes of a novice Python user that come into a growing ecosystem. And try to have some reflection, some question on that, and maybe step into one of the projects on the based on documentation that I've been working on. So a tiny bit about me, so that you understand where I came from, who I've been interacting with. I'm originally a physicist, and I did my PhD in biophysics that I started about 10 years ago. At approximately the time where I started to contribute to open source Python and to the whole Python ecosystem, because code that was shared in my lab was MATLAB with comments in German and files sent back and forth by email, which was really not the best. And I quickly became the person to talk to in my lab about computing, and I realized that most of the impact I had in science was more by helping others write code and to develop libraries. That's where I started to contribute to IPython, who became Jupyter later on. And basically, I said, like, okay, that's what I need to do if I want to push science forward. After that, I did a postdoc on Jupyter with Rolando Perez at UC Berkeley for about 2 years. So I had a lot of interaction, both from really novices users that basically had Jupyter as their entry point into Python, and expert users that were really pushing the limit of Jupyter. I also did a couple of years in research IT, again, at one of University California, Merced. We're helping people write their code again, improve their code, or push the limit of the supercomputer. And for the last 2 years now, I've been a software engineer at QuantSight Labs, trying to push what's a scientific Python ecosystem can do. And all of that in about 10 years. That goes really fast. And I realized that the scientific Python ecosystem has changed dramatically in 10 years. And if you remember, if you've been to SciPy 10 years ago and you would go to a tutorial, for example, you would see USB stick going around and people trying to install things. You had to compile SciPy, you had to go into each package manually and sometimes run setup.py. And the documentation was even present as PDF because you might not have Wi-Fi, and it was the beginning of all of the Python packages to go to GitHub. And fast forward 10 years, and now I can tether on my phone and install a couple of gigabytes of precompiled packages with maybe dozens, if not hundreds, of dependencies without paying a dime more, because everything is included in my plan. Virtually everything is on GitHub. And now we have CI, which means that things that were not working across platform now are always tested, and all your libraries always work, which is relatively great. And we've seen a tremendous growth of the Python ecosystem. Everything is connected. You have access to internet all the time. Package installation is much more robust and often easier. You have VCS everywhere, so you can get previous version, you can contribute, and it's really dramatically easier to publish your own package. And so the number of packages on PyPI and CodaForge has increased exponentially with time, which a lot of people are seeing as a really good sign that everything is working well. And so still though, when you see people that try to start working on Python, they struggle a lot. And if you spend time with them, you can realize that the gap in knowledge between what you have and what you need to start working on having Python set up is increasing. One of the reasons is that the skills are not the same. You might have seen last year or 2 years ago some articles about students in Python class that didn't knew what a file system was. And it's something which baffles a lot of people, but actually, if you use an iPad and a phone all day, you've never seen a file system. And if you want to use Python and you have to start with paths in some areas, people don't understand. And when you were trying to contribute to Python 10 years ago, you could basically count maybe all the critical package you needed on your hands and get the, talk to everybody, figure out which package you need, and you were good to go. You knew where things were. But now you have so many packages that it's really difficult to even know what to search. And because novices don't even know what to ask, as the Haystack is becoming bigger, they even have less chance to come across the right information if they just browse at random. And so flexibility and composability was an advantage of the Python ecosystem 10 years ago. And one of the questions is it still an advantage to be so distributed, to have so many packages in the near future, and in the long future, will it still be? I don't have those questions, but I want to make you those answers, but I want you to think about that. And there is still a big attractivity for all-in-one solutions, something like MATLAB and Mathematica. For someone who doesn't really care about exactly how things work internally, that if you want to read a CSV, you need Panda, and if you want to plot, you need Matplotlib. This is extra information you need to get in your head. Something where everything is there and you don't have to ask questions is really great. You have exhaustivity. You don't have to wonder, well, why can't I do that? Why do I need to install another library? It's also much better for searchability. Like I know that if I want to do something with a CSV, I need to put pandas as keywords in Google to find the results. But someone who is a novice will do, how do I do it with Python? And then they will be inundated with a flood of results, and they don't know which one to choose from. And there is also discoverability in documentation, because each library is developed independently and you don't know which library is on the end user's machine. You can't make assumptions, for example, in SciPy, if you want to show an image processing example, that the users can rely on scikit-image. So an exhaustive solution like Mathematica or MATLAB can make links to all those other things. And if you think about it, SciPy and NumPy at the beginning were partly created to have everything in one place. You want to do numerical computing, you install NumPy and SciPy. You don't have to install a package for just statistics or for just signal processing. That's why you have those packages. And so there is attractivity of having all-in-one. Is there something we can do for the ecosystem to look more an all-in-one for the end users? And there is some advantages of what I call recentralization. Like, for example, if you look at Git and GitHub, Git was really great and helped to develop the open source software much further than any other VCS. But GitHub had a tremendous effect of bringing people all together in the same place, where you only had this single place to look for and to look at things. Beanstar allowed everybody to publish binary package. Now it's known as anaconda.org. But CondaForge brought all the package together so that they work because they have the same binary interface. And there are a lot of others examples like that where centralization can be a good thing. But to a certain limit, when something becomes too big, there is too much surface for the users to search. There is a too big ocean, and so things tend to split or to form smaller communities. And so there is a challenge is to find a sweet spot between the size of each element and the number of each element. So that's why when I see that PyPI is growing exponentially, growing is fine. Exponentially, I think, might be dangerous for PyPI. We can see, for example, JavaScript, which has way more packages than Python and might be problematic. And so you can try to form superset of things, meta packages, or try to merge similar projects to have less surface for users, which might be a good thing, or try to cull old software, old code to reduce the surface area. And now I want to dive into one particular thing, which I believe is becoming hard, is a case of documentation. And sorry, I'm going to pick at some point at some libraries that some people in this call have contributed to. First, I wanted to talk about documentation in IDEs. So Jupyter, I wrote Jupyter. I know some things are wrong there. The best place to get documentation is right next where you code. And is, for example, you have the DPSS function of SciPy and you look at the documentation in Jupyter with a question mark, you get the source of the docstring. And this is not great for end users because you have raw markup files that are difficult to read, that doesn't have highlighting, and you don't get access to tutorials, you don't get access to galleries, you don't get access to plots, you don't get access to narratives. And I think that's really bad because when you go search online, you don't get often the right version or you have to find the right one. And maintainers are stuck in simple syntax because they know this is shown to the end user. So a maintainer will refrain themselves from putting a RST directive just right there because it will make the documentation less readable. And so often you're just seeing, for consistency, everybody uses NumPy doc plus RST, even if some maintainers would like to use Markdown, for example. They decided not to for everything to look the same. And same thing when you go online, you will get multiple domains. And I think multiple domains are extremely confusing for users. There is a no index, no follow problem. I took a screenshot of Matplotlib documentation today. I Googled something, I got to the Matplotlib documentation. It was the wrong version. It was not the latest version, and it's something which is hard to fix. And users get confused as well. I often see people what I call the it's not the green one problem, where they see the first useful documentation on one website that have a specific theme, a specific layout, and they associate this theme, this visual representation with this information is good and is correct. And now they will search help for another library. And in this case, the first case, I saw that the first website they saw was SymPy, which has a dominant green appearance. And as soon as they were coming to another website, like for example, pandas.python.org, they were like, it's not the right one, it's not green, and the URL is not the same. So therefore, it's wrong. And so now you have documentation which is spread across many domains, which confuses users as to which one is the correct one, which one is relevant. And it can be complicated to maintain updates for maintainers because they have to rebuild on each and every domain independently and update them separately. Though for some languages, there are platforms that exist, like if we take Rust, for example, all the Rust documentation of all library is in docs.rs with a similar theme everywhere. And there are others, platforms that try to do the same, like devdocs.io, that try to reassemble everything into something coherent. And I think we can do better. Sphinx, MKDocs, and a lot of others documentation generating tools have been created more than a decade ago or built on assumptions from more than a decade ago that you're not always online, compute is expensive, and basically you build locally on your machine and you push a static website. And I think we can do better. We should be able to do better for users. We want something which is called to the state-of-the-art of proprietary system, which is basically in your IDE, you get a docked browser with everything which is relevant to your system where everything is installed. It's much more difficult because proprietary system can build all the documentation. We obviously can't do everything at the same time because each library is maintained independently. And I want to demo to you, if it works, a framework I've been working on the past year and a half on. And I recently got a Chan Zuckerberg Initiative Essential Open Source Software grant to push that forward to try to gather all the documentation and make it work better. And so I hope it works because maybe I didn't write it 5 minutes ago, but an hour ago, just before this talk. And I'm going to show you some demo. So here I have a preset Jupyter lab. And the Jupyter lab here, I've imported the same function I talked about before, DPSS. And here I have the documentation as Jupyter is showing it. And if we forget about the right side for the moment, you see that it's relatively ugly. And what I've developed is an extension, a way of building documentation that would, on the side here, show the same documentation for DPSS. But not only is it well rendered, you also have all the graph, all the plots that you want. All the examples are type inferred. So if I wanted to go to Windows Kaiser, I should be able to click on it. And so let's see, let's try to go somewhere. Let's go to even across libraries. I want to plt.subplots. I can click on subplots and see the documentation from Matplotlib subplots. And not only I have access to like navigation across function, I can do back and forth, which is not implemented yet. I can also jump to narrative documentation if I want. So here I have the narrative documentation from NumPy. I have external links that I throw down external link. Not everything is implemented yet, but you have a lot of things, of extra things. And I'm going to cheat a tiny bit here and switch to actually an iframe because I'm not that good in JavaScript, but I know how to do some HTML. There is other things you can do with that. Like, for example, I want to have better crosslinks at interlinks. I want to know which page refer to this one. And I played a tiny bit with JavaScript and there, and I have all the local network of which page reference to each other with the size of the blob that represents the importance of the page. So for example, here I see that some documentation of NumPy is linking to SciPy and vice versa. And I can go to, for example, NumPy ngArray, and I have the documentation of ngArray. And here I have all the references across all the documentation of all the libraries of pages that reference ngArrays. So you see that NumPy ngArray itself, NumPy itself reference NumPy ngArray 400 times. SciPy reference NumPy ngArray 371 times. Scikit image reference NumPy ngArray 180 times. So now you can find things in other libraries than NumPy, even if NumPy does not know about those libraries that are useful with ngArrays. And you can do some other things, like, for example, have the gallery of all the plots in SciPy across all the functions. It's just native. You can automatically do that. And if you, excuse me, cheating a tiny bit, you can do more fancy things like finding all the math equations across all of NumPy. If I wanted, I could also find all the math equations across all the libraries. And so this helps you navigate across the documentation of all libraries as if it was a coherent, unified ecosystem. So this is still just a prototype. It's in development. So you see that there is still a lot of bugs here and there. But I believe something like that should help users find the right documentation, especially since the documentation you have here is the same version as the one of the libraries you have installed, and you don't have this mismatch of library version. And as well, something we'll see in the slides back, the rendering is separated from building the documentation. So if you want to do any update of the rendering, like for example, having a dark themes, or if you need more accessibility, or if you want to have a terminal browser, you could have that. So let's do, and hope, oops, that was badly rehearsed. And so here we have a terminal renderer. So if some of you are terminal users, you can navigate the documentation directly within the terminal and go see, make it crash. Okay, so let's go back to the presentation as it crashed. And so how does it work? Instead of building the final documentation, you do a trick that compiled languages have done for a really long time. You build intermediate representation. You build files that are not the final one. You get them together, you link them, and then you do, last minute, you do the rendering. And this allows you to do a lot of things, which means that you can work on the renderer separately from the builder, which means that you can tweak the representation, change the user preference, change the color, change a lot of things without having to rebuild everything from the original project. The documentation is also semantic, so you could imagine, for example, backpatching documentation. If you deprecate parameters, you could backport that to all the previous versions of the documentation automatically. You can have back reference, all the figures, find future deprecations. You could write docstring in Markdown, now that the rendering of docstring is separated from the source itself. And if you want, you could build a purely static website that renders all of the scientific Python docs and don't have users worry about how does it look like because it's a different domain or a different color. And I present that more in SciPy if you don't go come talk to USB. And I believe a unified experience is really important for users. The scientific Python ecosystem has pushed science forward and will continue to do so. And the next challenges are not going to be purely technical. So it will be about coherency, unity, and seamless experience. And as Antoine de Saint-Exupéry said, perfection is not achieved when there is nothing more to add, but there is nothing left to take away. So I want to take away everything which is extra from the end user's perspective so that they see the scientific Python ecosystem as something which is completely coherent and need to dig into the detail only if they want to. And I think I'm about on time, so I'm going to stop there and take questions.
Fantastic. I want to open it up to our host panelists, see if we have any questions or points of discussion here. And then if not, we can dive into the Q&A. I see there are a number of questions there that we can address.
So do I take question in order? Like what is the smallest tools that PyPyRE will benefit? I think it will help smaller tools more than it will help big tools, because the overhead of setting up a new domain, setting up read the doc and everything, and so on and so forth, is really high compared to the size of the project. My goal is to basically have something, you run the tools, it gives you intermediate representation, you upload it. I'm hoping to even have, Conda Forge automatically uploaded somewhere. And you don't have to worry about managing the appearance. It can be automatically done by the teams that manage PyPyRE itself. Like if, for example, we had, the good example I like is a Sphinx copy button extension from Chris Allgraph that needs to be installed on every Sphinx website one by one. You need to make a pull request to NumPy, you need to make a pull request to SciPy, you need to make a pull request to every Jupyter project. With PyPyRE, you only need to make one pull request to PyPyRE to render a Sphinx copy or to render a copy button, and suddenly every website, even old version of the documentation gets this improvement. And I'm not a UX person, I'm not an accessibility person, but I care about that. I care about diversity. I care about being able to read, having dyslexia, maybe a different font would be great. You can do that. You can suddenly do that for all the websites, all the documentation you want in a single, a single pull request, or even have a different subpath in your URL that renders things on the dark theme if you want.
Matthias, I want to push back a little bit on that, because if I am scientific computing staff and I'm relatively new to developing codes for other people to use, not just simple scripts for myself, just like in the extracurricular we did at the beginning, I'm faced with an enormous number of things to worry about. Unit tests, continuous integration, automatically generated releases, Conda Forge, read the docs, and all of that. And it would be very helpful for me to be able to align on a timeline, when do you need to start worrying about each one of these pieces? So for example, if I have 0 users, do I have to worry about tests? Maybe, maybe not, because if something breaks, who cares? Where do I start to worry about things like read the docs, things like your project? At what point do I have that switch flipped in my head and I say, okay, now I can take a deep breath and think about this?
I think about the same point where you would decide to publish documentation on Read the Docs. It's not meant to replace something like Sphinx. Something like PyTorch or TensorFlow that are their own website dedicated to them is not something PyPyRE is trying to cover. But if you just want to say, okay, now I want to publish docs, I want something which is sorry, my cat user is needing attention just right now. If you want to publish documentation, but you don't want to have to learn all about which theme do I use, which extension do I install, then this should be a sweet spot. So it's not for really, really super large projects that need their own website because they're also in C++, for example, or need to do access from C++. But for the medium project where you start to care about users, that should work.
I'm kind of curious to hear from the other panelists on the core topic. When do you actually start caring about documentation at all? Because you could just not. You could just put some code in the world and let people deal with it.
Well, if you want my opinion, I would say you start caring about documentation from your first line of code. I may be a crazy person, but I also have a terrible memory, and I find that I write code that to one time is very useful to me, and then I forget it exists. And then if I don't have it documented, I will come back to it. I will forget what it does, and I will inevitably rewrite the same thing, wasting my time. Something you write could always turn into, right, something other people could use. And documenting is not just for other people, it's also for you. Because, I mean, you could forget, like me, or honestly, it's just a good practice that has helped me write better code in general. If I'm forced to document it, right, it's very hard to document a function that does 85 things, but it's very easy to document a function that does one thing. So my argument would be there is no time where documenting your code isn't worth the time. It's always worth the time. Feel free to disagree. It's a pretty extreme opinion.
I agree with that to a large part. I think that your most common collaborator is your future or past self, depending on which side you're looking at it from. And past Tom is a jerk, in my opinion. I've also seen it. So our colleague Dan Allen has done something that sometimes I'll call tutorial-driven development, and then he'll actually write the tutorial to teach the library before we've actually implemented it. Because that, as you think through the use case, it's very much like the stories in Agile, where you're starting to think through what functions you need, make sure that it's easy to explain, make sure the inputs and outputs make sense and kind of flow through. And then once you have the tutorial, now you write the code to actually make it happen. Because in a lot of cases, actually, as that our warm-up exercise showed, the code itself, there's many, many ways you can get functioning code. It's usually much harder to figure out what code you should write than to actually write the code. Like, I'm not saying there isn't hard, tricky code in the world, but a vast majority of the code is straightforward, easy to, straightforward Python. But deciding what straightforward Python you should write is the hardest problem.
But I think we've all experienced that people don't write documentation, and I know that they have a lot of excuses that at the time seem very reasonable. And when I say people, I might also be talking about myself. I'm curious if the panel can push back a little bit on some of those common excuses and say why that excuse maybe doesn't hold as much water as you want. And similarly, there was a really nice question in the Q&A about how to document a software package. What are the best practices? Do you start with the traditional user manual, tutorials, or so forth and so on? So maybe that might be a nice segue into that as well.
I will say that it often depends on which kind of library you're writing or which kind of software you're writing. If you write something which is generally relatively low level, you can assume, and most of the time that's something I will do, it may depend also on which module you are in your library, that the people who will be using it mostly want technical documentation. And so mostly I will focus on docstrings, on class docstring, and so on and so forth. If you develop something like, I would say, scikit-image or scikit-learn, that are basically playgrounds for scientists to try to understand that data, then the kind of documentation you want will be different. Because what you will get is someone who wants to do a task. They don't care exactly about the detail of how the code works or how you can bring things together. They just want to get, I don't know, James with pink hair because they're doing machine learning. And if you're Matplotlib, well, the best page of Matplotlib is a gallery, because how do I write a plot? I go on the gallery, I find something that looks like what I want, I copy and paste it, and I modify. So this answer will depend on what your target audience is, what part of your library you're writing.
I completely agree with all of what Matthias said. That I have been poking around the Matplotlib documentation a lot, and I have mainly been hovering around all of the docstrings and API usage instead of the tutorials. And I find that Even going one abstraction level above, something like Seaborn, if you check their Michael Waskin's documentation there, that's almost all right. Here's just how you use the tool, right? Very little kind of API like under the hood usage, since it's an abstraction layer on top of what Matplotlib offers. And if you go really down to the depths, Matplotlib has, all of the very, very under the hood nitty gritty things that you don't need to concern yourself with most of the time, but it is there if you need to tap down into it.
And I'd love to hear panels talk a little bit more about this question about the different forms of documentation and the framing for that. And I'll add one more onto the framing of traditional user manual tutorials. How good of documentation is a published research paper with a link to, oh, I wrote about this in this paper at the very bottom of the thing, and that's the entirety of it. Does that actually help people? Because I've seen a lot of software that just has that one link.
I'm sure I'll get some pushback from some people, but I think the idea of a user manual, a static user manual, is like, that is so 10 years ago or something. If the code is alive, if it's growing and changing, I don't think, even for a fixed, because here's the thing, right? You can do in my opinion at least, you can do everything you can do in a fixed user manual with a dynamically generated documentation website. I mean, no one is printing out 100 pages of a user manual anymore. It just isn't what's happening, right?
I think that was a technical limitation, that you were not always connected, and so you had to download the PDF and skim through it, or print it if you didn't have always access to the computer because you were just going to the university library. To slightly respond to James, I've put a link in the chat. I don't know if it's the right place, that describes some of the different type of documentation. And I think it's a good framework that more and more core scientific Python library are trying to adopt.
Yeah, maybe to just reframe a little so I don't seem so dead set on my view. Maybe the answer for the general user is, do what makes sense for your use case. But I would argue that starting with doc strings is never a bad thing, and then just building from that. Because it's very rare, I think, that a code is just used for one single purpose and people aren't going to want to play with it. I mean, every code that I, picked up from other people, I got to play with it. I got to, there's some change I got to make. I have to understand something. And again, that person could always just be your future self, right? So maybe there is no correct answer. I do think that you can do anything you need to in a manual with a stamped version of your documentation online. But yeah, I would always start with doc strings and just build up from there for what you need, tutorials or some manual or something.
Matthew, most likely the participants in this call will be writing not libraries with 200,000 users, but maybe 20 users within their facility, maybe 200 users if it's very successful. Are there ways to write documentation so that people will actually read them? Because you may have put all the effort into writing those doc strings, but it's a lot easier for me to say, Matthew, can we get into a meeting for an hour? I have a bunch of questions, and for you to tell me over that hour, I wrote all of these down already.
Yeah, so that's a great point. No one wants to necessarily spend a million years reading through all the documentation, right? Such as the point. So yeah, what a lot of things libraries do. My personal recent favorite is LaGuru. I don't know if anyone's heard of it. Put it in the chat maybe. But LaGuru is cool because if you go to the overview, they just have a list of like features ready to use out of the box, right? And so maybe for the the person who's writing a package for their user facility or something, right? Maybe it is the case that people don't want to get into the real nitty gritty of all the pieces of the API, but they may want to have like really quick tidbits of code out of the box that work, right? That are very transparent, very easy to use. And so I think, again, like I said, you can always refer back to specific functions if you've documented them, right? But to answer your question, having small bite-sized tutorials, no one has an attention span of more than 5 minutes these days, right? You want small bite-sized chunks of code that people can look at really quickly, determine what it does, and say, yeah, okay, I can use that in my work, like no problem. Because if they can't say that, they're not going to use it, right? It's not going to be useful.
Yeah. Thanks for bringing that up, and James, for posting the link there in the chat. After visiting the page, I was quickly reminded of the absolute most important piece of documentation that you should always probably start with, or maybe second level. It's the README on your repo, right? If you don't have a README, or if it's a fairly sparse README, chances are I'm not even going to install your package. I'm just going to be like, well, I probably don't need this if I can't see what it's doing, what its purpose is. So I would definitely start with the README when documenting.
That's also
seeing. Oh yeah.
That's also true of blog posts. I often read blog posts about, hey, this is version 3.5 of this library, and I'm like 2 paragraphs down, I still don't know what the library does. I'm just like, okay, I'm going to stop reading because I don't understand what you're talking about. So even when you address your regular users, remember that some of them are new users and don't know what you're talking about.
So maybe put the main point of the library up top in your blog post, and then, for the more technical people, put it down on the bottom, because they'll get down there anyways if they're already a dedicated user.
I'm curious, Tom, what percentage of Matplotlib users actually read the Matplotlib documentation before taking to Twitter or Stack Overflow to complain? And one, is it still worth it to put all that effort into the documentation facing that? And two, how do you try and convince those users to maybe help themselves before they take to social media?
Well, I suspect the fraction is actually who just go straight to social media is actually quite low, because we have a lot of users, and there are. Oh, I see. What fraction of James's go straight to the social media? That's a different question, James. I think it's still worth it because our users, by and large, are very clever, capable people who are motivated to solve their problems. And if you have enough breadcrumbs and signposts that guide them, like what is possible, and then a combination of the gallery which shows you what's possible, the straight API docs to say, if you have this function, what are all of its arguments and how do they fit together, along with some longer prose explaining the philosophy of the library and how it works. Users will find their way through that and be able to help themselves for the most part. And even if they don't, and they show up and they ask questions, if you have pre-written your answer down, it's much easier and faster to send them a link to the documentation than it is to type it out again. This is also something, a practice we try to do at NSLS2 is that whenever we get a question about the software we're developing that we really don't have documented, we'll answer it with a pull request to our docs that answers the question there. And that way, the next time we get that question, we have it pre-written. And that you're using, the feedback from the user, what their problems are, is telling you, where the interesting cow paths are and what is underdocumented and what people are actually using your code for, which is not always what you imagined it would be used for.
As a follow-up question, I'm curious, if you were a journal editor or somebody in a position of authority within the peer review system, and you got a submission that didn't include the source code for some critical portion of it, you might reject that submission and say, look, this is not reproducible unless you give us a source code. What if you got the source code, but it wasn't documented? Would you reject a paper that includes source code that is not documented?
I think that's. Go ahead.
I was asking, which field of science are we talking? Because
let's say X-ray physics.
Oh,
I think that highly depends on what the current state of publications is in the field. Depending on the field, if it's not common and the authors submitted the code, I would say yes. I wouldn't highly grade the paper. I would praise the paper more if the documentation was there, at least to give to make it standard that papers should publish code. And as time goes on and the quality of papers and the submission become a normal process, like the submission of code become a normal process, then I'm going to be more picky about what the codes need to look like, whether it needs to be well documented, whether it needs to be well structured, whether it needs to follow PEP8 or use a recent version of NumPy or have CI. And that's changed depending on the surrounding context. There are definitively fields where if there is no code, or even if there is no dependencies and the dependencies are not pinned, or there is no seed for the random generator, I would refuse the paper.
Is it really reproducible research if you can see the code but nobody knows how to use it because it has no documentation?
It's depend what kind of code. If it's, using it might be just doing Python myscript.py and you get the result. That's usable. There is a question between reproducibility, replicability also as well, which is can you press a single button, get the same result? I don't care whether the result is correct or not. Can you do that? Docker was assumed to be the solution a couple of years ago, which is definitively is not, because if you have just a Docker file and you rerun it often, it's not reproducible and the image tends to go away. So can you have a single press button, I get the same result, is already one step. Can I take this software, rerun it with the newest version of the libraries and get maybe a better result or a faster result? Because the library have improved is a second thing. Can I reuse it and plug my own data or change the model is yet another step.
I think this is a fascinating question because it really touches on what does it mean to be reproducible. And so if I think about what it meant, what it means for experimentalists, it means, I can take the same I take the same sample and run it on my instrument with the same settings and get some consistent result, right? So I agree in principle, code should definitely be documented. And I hope, as you're saying, Matthias, that we get there, right? Because culturally we're not there. But, at least in physics, I feel we're not there. Physical review would never care. They just don't ask, right? I've reviewed papers. I don't ask. No one asks. It'd be great to get to a point where you have to do that. And that would force institutions like Brookhaven to really be very pro open source, and be amazing. But I wonder too if there's some benefit in terms of the reproducibility side on the science side, right? Does reproducible with a code mean not using my code for your data? Instead, you rewrite your own code. You write your own code using the same method, right? The same mathematical framework or whatever to get a consistent. So I don't know the answer to that question. I think that's the way we do it today, right? In grad school, I was doing physics projects. That's the way I did it, right? To reproduce previous results in papers. I never asked for their code. I just wrote my own. It was almost like a sanity check.
Yeah, and I'm going to push the question a tiny bit further. Is that the scientist's job to know and to learn how to write and properly publish library code? I think, already doing typos work and making graphs and all the submission process to journals we used to be much more reliant on, we would say, here is something, please put it in the final form, fix the typos, make the graph, and I'm going to vet it. Now scientists are doing all the work. And so I think for the fees, the journals are costing scientists. Some of that work should be part of the peer review process, not always a reviewer. Maybe, if you were paid and if reviews was part of what is recognized for careers, as a reviewer wouldn't mind helping authors put their paper in a good shape. I just need a process which is not annotating a PDF and sending review backs after 9 weeks. I need something like GitHub-ish. If we want anonymity or something around anonymity, but having a way for reviewers to prove when they want to do that they have reviewed a paper, signature or something like that, that would be great. You interact with your reviewer, you improve your paper with your reviewers, you get better science in the end.
I like that. I'm curious, Matthias, have you pushed code like through the peer review process for any scientific projects?
I've tried. Most of the time, the journals are not made to do that. I've reviewed books and basically had side channel communication with the author to basically bypass the journal and have something which is faster. But no, not that much. And I think there is a lot of technical things that we could do in the way we write paper, but that would need a massive investment and a massive platform, which nobody is ready to take on.
Yeah, because you have things like the Journal of Open Source Software that that are specifically for these types of projects, but a lot of times it doesn't make complete sense, right? If it's a very niche kind of tool that you're writing, it might make a little more sense to publish it in more of a domain-specific journal. And so I think it's a huge ask to have those domain-specific journals, to have individuals who, do software review and will actually understand the code that they're reading instead of just trusting the author that, oh, yeah, I buy it. I'll buy the code. I can critique their ideas and their theories. Code, I guess, will do, whatever it is.
I mean, in a large sense, it's a money question. If it was a job and there was money for it and people were paid to do that, there would be full-time people to help with it. But publication is often a money-making process. And for a journal like JAWS, people are mostly free. People do it on volunteer time. They can't offer that much help. I would much prefer for Elon Musk to give that much money to create a platform to do that and to buy Twitter. I think that would have a much better impact on work. And there is also the fact that papers are still stuck with quotes in PDF world, where I think now with an interconnected world, I would love for every individual result on the paper to have its own DOI. And when you cite a DOI, you can cite with a reason. Like, for example, I rely on, I disprove, I find the same result. The meta-analysis you could do on papers there would be so much more interesting, because right now, citation games, like the number of citations you get can be really high, even if your result is wrong. And as someone who reads paper, you see, oh, this paper has that many citations. It must be good. Except 95% of the citations are basically, no, this is wrong. And you need to go to all of these papers to figure that out. And there's a lot of things you can do, dependency analysis or pre-shaking, where if you say if this paper is wrong, then all those papers might have been disproved or might have been to be redone because this result is incorrect. And I think there is a lot of interesting possibilities that you can do with software on the publication side that we haven't even scratched the surface.
Yeah, I agree. I think, I was just going to agree. I think there's a lot more work to be done, especially as we consider code, being part of the scientific process. It seems nowadays, at least in the field where I come from, more and more code was being pushed, as part of the scientific process. And so, we need kind of reviewers or people who are willing to lend their time, unfortunately, because a lot of review work is completely unpaid, unfairly. To be up to the standard, not in just the domain-specific knowledge of their field, but also a little bit of code as well, as it seems to encroach upon our daily lives.
So I have an opportunity that I want to present to our host panelists, our guest panelists, and maybe even our audience. As many of you know, I serve as the chairman of the NumFocus board of directors, where NumFocus is the 501c3 nonprofit that physically sponsors projects like Jupyter, Matplotlib, Pandas, and so forth and so on. Becoming a NumFocus project can sometimes be a very big deal because it gives availability for large-scale funding of that project through grant mechanisms like CZI. As part of the board of directors, we evaluate whether new projects should become NumFocus fiscally sponsored projects. And the evaluation criteria are fairly straightforward. Is the project open? Is it led openly? Does the project have a community that needs being supported? And is the project kind, inclusive, a good environment for people to contribute? Under the open side, you could make a case that a project with insufficient documentation is not sufficiently open because you cannot have outside contributors come in and help out with the project if they can't make heads or tails of it. If you were to give me some advice evaluating whether a new project should become a NumFocus project, what level of documentation would you say is appropriate for me to say, no, this project is not open because there's not enough documentation for somebody to actually contribute to it to use it? And I actually will try and use those criteria in the future if I like what you say.
Oh man, that's a tough decision, right? It's a tough call. It's how big is a mound? Oh well, it's smaller than a hill. So I'm curious, does anyone even have thoughts on where to start? Right, we've mentioned aspects like readmes, docstrings. Tom?
I would start with the test of, can I, without speaking to anyone on the project, get it checked out, built, and then use it for its intended purpose? And then check later, like, did I actually discover its intended purpose? And I guess the last would be like, and then did I figure out where I could open a pull request if I found a bug?
I think there is also a question of is there actual work being done on documentation? If the product is not completely documented, but you see that there are regular contributions and that the contributors are starting to work on documentation regularly, then it's more a question of, is there an effort on documentation than is there document? I think that's also a good, it's like depth and deficit. You talk about the derivative and not the total value. I also want to say, like, again, as I said in my talk, you also often want to have less and more. And so the quantity of docs might not be a good factor. There is also a question of, when you review projects, I think at some point one of the criteria for evaluation is how much you remove old code, how do you clean up documentation, do you follow things like NEP 29? Are you a project that is following the cadence of the scientific Python ecosystem?
This is a real doozy of a question, because when you think about the huge open source libraries out there like NumPy, I mean, my goodness, right? Where do you start with NumPy? But NumPy clearly deserves, some fiscal support, right? I would throw the question back at you in a slightly different way, because I actually agree mostly with Tom's answer after thinking about it. But I would also say it's not even just the documentation; it's the code quality, because if the code quality isn't up there, right? I read a stupid inflammatory Medium article where it was like, stop documenting your code. It's just dumb, right? But their argument was somewhat like 10% of it was sensible in the way that you should also not just focus on writing good documentation, you should focus on writing good code, because good code can sometimes, in a way, document its purpose itself, right? So I would say also consider not just the quality of the documentation, but also the quality of the code itself, right? Is it readable? Is the code itself readable? Because otherwise, I don't think you can just say, like, is 90% document. I'm not sure that's a good metric, So.
Yeah. I think it's really hard, especially with those large projects, right? Judging any readability. I have been through a lot of Pandas internals right through GitHub, and it is very hard to make sense of all the layers of abstraction. I think just calling .sum on a Pandas data frame calls something probably like along the lines of 10s, 20s, 30s Python functions before it actually induces numpy.sum, or depending on what data type you're working with, the actual .sum. And so even I think Pandas is a great documented library, but the code quality, it could be the most pristine thing I've ever seen in my life. But the fact that there's hundreds of thousands of lines of code makes it very hard to read unless you're already up to speed with how those internals work. And to, as notice that we're encroaching on our end time here, I do want to end us with one final question. If every line of code you write is a liability, isn't every line of documentation an obligation to keep it up to date? Which is worse, no documents or out-of-date documents? How do you keep documentation fresh without constantly chasing after them?
I can answer this. I would rather have no docs than docs that mislead me. If there's nothing there, then at least I know I have to figure it out myself. But if I think I can figure it out myself with some docs and then waste my time, I'll be more upset than otherwise.
I agree.
Yeah.
I wrote some toolings to try to catch inaccurate documentation that I need to work on as well. Because I think that our inaccurate documentation is the worst.
So, Matthias, we'll see you in 6 months, and you'll have another presentation of how to keep your documentation fresh.
I don't know. Maybe once I finish this project, I can ask for another funds to die, and if I get another $250,000, maybe.
Just use Jupyter for all of your documentation and have it execute on a GitHub action.
I mean, not all documentation can be executed because a lot of the documentation is actually narrative.
Yeah, narrative documentation can go stale. That's very good.
And we haven't touched about translation. Oh, I see James citing as a non-native English. I have also strong opinion on that. We can take another time in 6 months.
All right. Fantastic. Well, on that note, I will wrap us out. Thank you, everyone. Thank you, Matthias. Thank you, Matthew. And thank you, Tom and James, for participating with us today. Matthias, we had a great discussion, so I appreciate the energy that you brought along with your prepared remarks and the discussion questions. And thank you to everyone in the audience. We really appreciate the interaction in the chat as well as the Q&A widget. I had a blast. I think everyone else had a blast. Panelists, if there's any final remarks you want to share with our audience before we sign off, we'd love to hear them now, starting with Matthias.
Feel free to contact me in side channels if you have questions or interests. I'm always open, especially for diverse and minority folks. It's not always easy to go in public channels. My DMs or mails are open.
And Matthew?
Yeah, I was going to say something very similar. You can find my staff page at BNL. My door is, metaphorically speaking, always open as well. Feel free to email me if you have a question or, a project idea or you want to collaborate or whatever. I'm totally open to that. So it's been a lot of fun doing this. Thank you.
Great. And Tom?
Thank you for having me again. I apologize for my technical issues and not having video today. Guys, if you want to email me, I'm also open. But if you're asking for Matplotlib support, I will push you to public channels.
Great. And then James, any final thoughts?
As we saw in our extracurricular at the very beginning of this session, the number of choices can be absolutely bewildering. And it is very much the case that if we are to complain that scientific users don't write documentation or their code isn't always up to a certain bar of quality, Well, what do you expect? We're asking people to be absolute experts in their own domain and then add on yet another set of layers of expertise, which itself have expertise in documentation and packaging and code writing. This is a lot. This call's purpose is to help you navigate that extremely complicated, extremely demanding set of new obligations that are coming up in your work. If you find that you are overwhelmed trying to figure out how to get started with, what do I do for packaging? What do I do for continuous integration or for testing? Somebody said I need this. Do I really need it? Please, I really encourage you to join us for future calls and to reach out to us outside of these calls, and we can take your questions and open them up to the entire group. All of us here on this call and all of your host panelists, many of whom could not be present this month, are here to support you in your use of open source scientific computing, and largely more specific to that around the Python and the PyData ecosystem. We want you to succeed. We want to provide you with the resources and the help to succeed, and we understand how much of a challenge it is for all of you. And so please do not hesitate to reach out to us. Do not hesitate to ask questions, even if they're really simple, like Cameron said, GitHub Actions. What the heck is that all about? And how can that actually help me in my day-to-day life? We'd love to hear from you because we want you to see that this can be a thriving ecosystem that can benefit you in your day-to-day work. Now, with that said, Cameron, one final very quick question, and then we'll wrap. Who's going to be joining us next month?
Next month, we have, I believe it's Matthew Fikart from the Iris HEP project. So we'll be hearing from him. So make sure you join us next month when we hear from him for the next iteration of the Department of Energy Python Exchange. All right, and on that note, we will wrap up. Thank you all for joining us. It has been a pleasure, and I hope to see you all next month.